Hello everyone. Today we're going to learn lesson 13.1 day 1 and we're going to begin the unit on exponential growth functions, and we've been already exposed to exponent functions a little bit from module 12 when we had the f of n function equals for the geometric sequence a1 times r to the nth power. So that was the beginning of an exponential function. And as we recall, there were two types of exponential. There was a growth and there was decay. So we're going to take a look at what situations we will have growth and which ones we will have decay. And today you are going to be sharing triad problems and to understand the basic function for an exponential model. So let's take a look at the first equation. F of x equals b to the x. Notice that b is the base and b should always be greater than 1 for an exponential growth. And notice that x is in the exponent position. So this is how we form an exponential function. In the first example, we're going to take a look at f of x equals 2 to the x, and we're going to let x be these numbers here, and we're going to obtain the range. So this will be our domain, and this is the range, and we're going to figure out what is the y value. So letting x equal -3, we will have 2 to the -3. Which means to make a negative power positive, we put a 1 underneath it, so that will be 2 to the third power, which is 1/8. And for the sake of graphing, we're going to approximate that into a decimal. So 1 divided by 8, which is 0.125. And let's place that point on the graph right now. So we have a -3 and 0.128, which is about 125 right there. And next, let's take a look at when x equals -2. So it's 2 to the -2. That will be 1 over 2 squared, or 1/4, or 0.25. And so at -2, that will be 0.25, which is halfway because that is 1. So 0.25 is a little bit above the 0. When x equals -1, that will be 2 to the -1, which is 1/2, or 0.5. And this is -1, 0.5. So it's a little higher than the previous one. And when x equal to 0, that will be 2 to the 0, which is 1, because anything to the 0 power is 1. So at 0, we have 1. And we're going to keep going and raise it to the first power. That will be 2. So at 1, it will be 2. At 2, it will be 4. And at 3, that will be 8. 2 to the third is 8. And there it is. So that would be the graph, and this is a function. It actually has an equation, so we're going to actually connect the dots, and this is the function for f of x equals 2 to the x. And next we're going to answer the question for part C, what is the domain? As you can see, this function, it goes left and right. When we go left and right, this graph is continuous for all numbers. So it keeps going to the left side. That's why there's an arrow there. And it keeps going to the right side. So the domain for an exponential growth function is all reals. And we're just going to write all reals. And the range is, as we take a look at the function, it is above this x-axis. So we say that the range is going to be y greater than or equal to 0 because the graph is sitting above the x-axis. The y-intercept is, we have when x equal to 0 is when we have the y-intercept, and we notice that that is the y-intercept right there. So the y-intercept in this case is actually equal to 1. So y equals 1. And the last question, as the value of x increases, the value of the y also increases, because as we go to the right hand side, the graph is actually, the values are going up. So we can say that it increases as well. So that is the first example, taking a look at the characteristics of a basic exponential function. And you guys are going to pause the video right now and try this problem, because it's the same exact thing as what we just did. So make sure you try the problem before you go on to see the solution. And now that you've had a chance to try it, let's go ahead and work it out again. So this will be 10 to the negative 3, which is 1 over 1,000, or very small, so 0 0.001. And this is 10 to the negative 2, which is 1 over 100, which is 0 0.01. 10 to the negative 1 is 1/10, or 0.1. And again, 10 to the 0 power will give us 1. 10 to the 1 is 10. 10 to the second is 100, and 10 to the third is 1,000. So there's a very big wide range here, so we are going to just only graph part of it. So at negative 3, it's going to be very tiny. At negative 2, it's tiny. Negative 1 is still tiny. At 0, it's going to be 1, and then it's going to jump. On 1, it's going to go all the way up here to 10. So notice there's a very big range here. So we're going to just do the best we can to connect. And the graph is going to keep going up. So the numbers get really big because the base is a lot bigger than the last one. This is 10. It's being raised with a base of 10, so it's going to be a very steep graph. And you notice that the graph looks a lot steeper than the previous graph when the base is 2. So that's why. But it has the same characteristics of the previous function. So for example, the domain is still all reals because the numbers keep going. So the range, that the graph is continuous left and right. So we're going to put all reals. The range, again, this graph is sitting above the x-axis. So we still say that y is greater than or equal to 0. The y-intercept, notice, when x equal to 0 is the same as the last problem. When x equal to 0, y is equal to 1. So think about that. Is that a pattern, or is this actually true, would be true for all exponential growth? So I want you to think about that for a minute. We're going to address that later. So the y-intercept in this case is 1. And again, as the graph, the value of x increases, we can see that the numbers are getting bigger. So the y values are increasing as well. So the function is increasing. And let's take a look at these discussion questions. Number 1, will the domain be the same for every exponential function, y or y not? So if you think about the graph y equals b to the x, anything base, so we're looking at the x value because domain is the x value. So think about all the possible numbers. Is there any restriction? And the answer is no, there's no restriction. You can raise a base to any power, so all powers would work. So the answer is yes, will be the same. For the domain will be the same for every exponential function. You can raise all of them to the same power, to any power you want. Number 2, will the range be the same for every exponential function, and where b is a positive constant? So if the base is a positive number, they're saying that will the range be the same? So notice that we have already looked at 2 graphs and the range is always above 0, which means it's positive. So if you raise a positive number to any power, you should be able to get a positive number. So you'll stay always be greater than 0. So the answer is yes, that y will be always greater than 0. And the last one is, will the value of y-intercept be the same for every exponential function? So remember I asked you to think about that question earlier. Yes, the answer is yes, all of them will be equal to 0, equal to 1 actually, because any base to the 0 power is always going to give you 1. And that is all the discussion questions. Now let's take a look at this important formula. This formula is going to drive the lesson for the next few lessons, because this is the basic function for an exponential function. The first number here in front, as you know, will be a vertical stretch, and this will be, h will be the unit to the left or to the right, and this is the up-down translation, and those are the components. And notice that the function is always going to have all real domains, and the range is always going to be greater than that number in the back, k, and that asymptote is going to be the y equals k. In fact, this is going to be a horizontal asymptote, HA. And these are the reference points that you will need. We only have 2. Remember the reference points? Those are the points that map up the function. So we will need to refer to these when we're doing the calculations. And in general, let's explore what the functions for the exponential looks like. So we have a b of x, which is going to follow this pattern. And this is for all growth, which means b is always greater than 1. So it will follow that. And then in general, we will have this equation. Notice that the only thing it does is it has the a, the h, and the k in there. So it will cause the original graph to either shift left, right, up, or down based on the numbers. And we are going to try the first one. So here's an example based on what we saw. We can see that there is, let's go ahead and name the transformations. So remember, the transformations are the numbers that are going to cause the graph to change. So there's a 3 in the front, which means there's going to be a vertical stretch of 3 units, just like we have learned in the past. And based on that number, we're going to have a 1 unit shift to the right, and then 1 unit up. So those would be the transformation. So 1 right, 1 up, based on the equation. And let's answer the question, what is the domain? Since this is an exponential function, and remember we said that the domain will be always all reals. So based on this, we can say that the domain is all reals. And the range is going to be this number right here. And since this follows a regular, normal exponential growth function, we're going to have the range is going to be y greater than 1, because it's going to be above that line. In fact, we have a horizontal asymptote at y equals 1. Remember, that is going to be the horizontal, and we can go ahead and draw that right now. And there is the horizontal asymptote. Okay, and that's y equals 1. That's the horizontal asymptote. And then the next question is, we're going to use our reference points. So like in the past, we have to bring our reference points, and based on the transformations, we have a x values are here, y values here. The reference points are 0, 1, and 1, 1b. The base is actually 4, so we're going to use 1, 4 for our reference point. The horizontal shift is going to be 1 unit to the right, so we're going to have x plus 1 as the transformation equation. And there is a vertical shift, so it's going to be 3. Remember, we read this whole thing as y, so it's 3y plus 1. And those are the two equations. So let's just do the math. So we have 0 plus 1, which is going to be 1 here. 1 plus 1 is 2. And we got 3 times 1 plus 1, that's going to be 4. And 3 times 4 plus 1, that's going to give us 13. So the 2 points that we have are 1, 4, and 2, 13. So if we're going to map those 2 points, we should have our function. So at 1, 4, it's going to be right there. And at 2, 13 is going to be probably right there. So let's go ahead, and don't forget, we always have the y-intercept. The original y-intercept was here, but now it's been shifted. So here is our new graph, and there it is. So this is how you graph from beginning to end. So we're going to follow these steps. Make sure when you do your homework, you're also following these steps A, B, C, D, E, 5 steps to graph. Now it's time for you to pause the video and try this problem before you go on. And hopefully you've had a chance to try the problem. Let's take a look at again the transformations. First thing we notice is that there's a 4 in front, so it's a vertical stretch of 4 units, and then this is a +2, which means it's the opposite, kind of reverse, so we're going to have 2 units to the left. And then in the back we have a -6, so that's going to be 6 units down. So those are the transformations. And let's take a look at again the domain. Again, this is an exponential function. The domain is going to be all reals. The range is going to follow this number here. This graph is going to be above -6. So y is greater than, and then we have a horizontal asymptote at y equals -6. So let's go ahead and graph that horizontal asymptote, which is right there at -6. And the reference points, again, we're going to create our reference points based on the transformation. So for our x value, since we went 2 to the left, it's going to be x minus 2. And then we're going to have 4y minus 6 as our y reference. And then the 2 reference points that we will use are 0, 1, and 1. The base is actually 2, so we're going to have 1, 2. And let's do the math. So 0 minus 2, that will be -2, and then that will be -1. And doing the math for the y, it's going to be 4 times 1 minus 6, and that will be a -2. 4 times 2 minus 6, that will be 2. So we're going to graph this, and then that will be -2, -2, -1, and 2, and the graph is right there. It's above -6, like we said. So this is how you graph. Go ahead and get started with your homework, and it's going to be day 1 book work. HRW, get started, copy the notes, and don't forget you have Alex for this week. And have a great day.